Hi everyone, and welcome back to Hexagon Purus Capital Markets Day. As mentioned previously, my name is Mathias Meidel and I'm Director of Investor Relations in Hexagon Purus. And I will be moderating the Capital Markets Day from the studio here in Oslo. From the studio, I'm joined by Company CEO Morten Holum, Company CFO Dilip Warrier, and EVP Light Duty Distribution and Cylinders Michael Klaczynski. And via Teams live from Los Angeles, EVP Systems, Todd Sloan. The agenda for today includes a corporate update by Morten Holum before we dive into presenting our hydrogen cylinders and system solutions by Michael Klaczynski, followed then by a 5-minute break before we get a presentation of our heavy-duty truck application solutions by Todd Sloan. We will end the Capital Markets Day with an update on financial and outlook from Dilip Warrior before we round up with a Q&A session. So please feel free to enter your questions via the function on your screen, or alternatively send your question to ir@hexagonpurus.com as with the Q1. With that, I will pass over the word to you, Morten, who will take us through the corporate update.
Thank you, Matthias, and good morning, everybody. I'm very happy that you have chosen to join us this morning, and I hope that the program that we put together will give you a better view of who we are, what we do, and where we're headed. So I want to start by putting what we do into a bit of perspective and highlight the role that we play in the overall transition toward a more sustainable future. And sustainability, that's the end game. That's what we're working towards, our guiding light and our true north. We are in the very early stages of the energy transition. Over the next couple of decades, the world will transition away from fossil energy and towards renewable energy sources. This is a major shift that will result in significant changes to the world's energy system and to all our mobility platforms. The world's vehicle fleet will be electrified because they need to run on renewable energy instead of gasoline and diesel. And they will be zero emission in the end, fully carbon neutral. Zero emission used to be about clean air, to prevent pollution in inner cities and densely populated areas. While that's still true today, it's much bigger than that and more ambitious. It's about saving the planet and preventing the devastating negative effects of global warming. And during the past few months, there's a third layer to this story: energy independence and national security, limiting the dependence on unreliable suppliers in times of crisis. And this third layer will serve as a significant accelerator to the energy transition. And hydrogen will play a key role in that. Hydrogen has gained remarkably strong momentum during the past few years and will play a key role in the energy transition. That's because it's the only realistic technology with the potential to provide a solution to the climate crisis. It's a great way to store and transport intermittent renewable energy. It's relevant across the entire energy system, and it makes it possible to clean up sectors that are difficult to decarbonize with other means, such as, for example, heavy industries, heavy-duty transportation, and so forth. It may not be the only solution, and it may not solve all problems, but there are no realistic pathways towards a net zero society without hydrogen playing a significant role. Every sector of society will need to reduce harmful greenhouse gases from their operations. The transportation sector is responsible for almost 20% of global CO2 emissions. And these emissions will need to be cut by 75% by 2050 if we're going to meet the 1.5-degree target set in the Paris Agreement. This will require three things. Vehicles will need to be zero emission and electrified, either battery electric or fuel cell electric, so that they can run on renewable energy. No tailpipe emissions or tank-to-wheel emissions. Number two, the supply chains, including production and distribution, will also need to be zero emission. And three, there needs to be enough renewable energy available. Then we will achieve zero well-to-wheel emissions. and Hexagon Purus has an important role to play in achieving that target. We are a technology company providing zero-emission mobility solutions. We focus mainly on two areas. One is the mobility applications, the vehicles themselves, providing energy storage and vehicle integration. The other is the infrastructure side, the stuff that's needed for people to use the vehicles. Hydrogen distribution modules, stationary storage, mobile refueling, and so forth. We provide technology that enable vehicles to run on renewable energy. And as such, we play a key role in the energy transition and in the overall quest to remove carbon emissions from the transportation sector. And there are two main technologies to support zero-emission drivetrains, hydrogen and batteries. These are often talked about as opposing technologies, that it's either one or the other. We don't see it that way. We believe that these technologies are complementary technologies and that both are relevant. Each has its pros and cons, and which one you choose, that's going to mainly depend on the customer requirement and the duty cycle that the vehicle needs to serve. Battery technology for vehicles is by now well proven. Batteries provide very efficient energy storage, but they're heavy and take a long time to charge. Hydrogen technology is a few years behind in its maturity, and although this is less energy efficient, it gives you those things that you don't get with batteries, longer range and fast refueling. So the main rule is the shorter the distance and the lighter the weight, the more batteries will be competitive. And the opposite of that, of course, is the longer the range and the higher the payload, the more hydrogen will be competitive. So looking at this illustration in the middle, you see these two key parameters of the duty cycle, payload and range. And you see the typical zones that are favorable for each technology. So let's take a couple of examples. Passenger cars. They are reasonably lightweight and don't have much payload. And the majority of them typically travel fairly short daily distances. We believe that most of those will be battery electric. The typical electric passenger car today gives you 400 to 500 kilometers of range, which is more than enough for most people. And you can charge it at home during the night. There will likely also be some hydrogen electric passenger cars, those towards the heavier side of the spectrum, or those that require more continuous use. But most of them will be battery electric. Another example is a medium or heavy-duty truck that can either be battery or fuel cell electric, depending on the duty cycle. If you run short distances, let's say below 400 to 450 kilometers, and you carry light loads, and you have a duty cycle that enables charging at night, then battery electric can work. On the other hand, if you carry heavy loads over long distances, you need hydrogen. Batteries are heavy, and to get enough range, you'll need so many of them on the vehicle that there won't be much weight capacity left for payload. And that's where truck operators get their income, from payload. And the long charging times required to get that amount of energy into the battery does not work very well for line haul either. You need some sort of fast refueling solution. So we believe the majority of the medium and heavy-duty trucks will be hydrogen electric. And then there are some solutions where both batteries and hydrogen currently struggle. Heavy energy applications, such as airplanes and ocean shipping. There's likely to be a small portion of those segments that might work with liquid hydrogen, but most of these applications will likely require other solutions, like liquid ammonia or synfuels. We are convinced that the best way forward to decarbonize the transportation sector is a combination of battery and fuel cell technologies. Besides reducing the dependency on any one single technology, it will also reduce demand for scarce mining resources and reduce the need for costly and cumbersome upgrades of the electricity grid. It will also allow regions with structural renewable electricity constraints to keep hydrogen as a molecule for as long as possible, instead of converting it into grid electricity. So again, we believe that battery and hydrogen technologies should not be seen as competing technologies, but complementary. And even a hydrogen truck, by the way, has a battery pack on it. It's essentially an electric truck with a hydrogen range extender on board. So let's look at how we fit into the overall value chain for battery electric and hydrogen electric vehicles. We're not involved in energy production. We provide the energy storage systems, either hydrogen storage or battery systems. And these systems go on to the end-use applications, the vehicles, and we make energy storage systems for a wide range of vehicles across the mobility spectrum: cars, buses, trucks, trains, maritime vessels, and also for the infrastructure part as well: distribution modules, stationary storage, and mobile refueling units. And in North America, we also provide electric drivetrain integration and full vehicle integration for medium and heavy-duty trucks. Again, both battery and fuel cell electric. So we provide energy storage technology that enables vehicles to operate on renewable energy. But we don't provide the electrons, we don't provide the molecules. And let's then zoom in on our part of the value chain and look more closely at what it is we do. So we work on 3 different levels: the component level, the system level, and the vehicle integration level. So starting with component, the core component in our offering is the hydrogen storage cylinder. The Type 4 cylinder is a pressure vessel that has a polymer inner liner overwrapped with high-strength carbon fiber. This cylinder is extremely robust and durable, while also lightweight, which makes it ideal as a tank to store compressed hydrogen gas on board vehicles. It's far from a trivial component, since hydrogen is typically stored at an operating pressure of 700 bar. But as I will show in a minute, we have several decades of experience with this technology and know it very well. So we can sell this cylinder as a component, and there are some customers that prefer that, but most often the cylinder is sold as part of a system. And the system is simply a combination of cylinders placed into a metal frame, complete with valves and piping and regulators and so forth, that feeds the hydrogen from the cylinder to the fuel cell or wherever it needs to go. The system can either then be a storage system for vehicles, or it can be for distribution or infrastructure purposes. Michael will come in later and explain this in more detail. And Todd will cover the battery system, which is a similar concept really, a collection of battery cells packaged together and optimized for storage of electrons on board a vehicle. The third level is the vehicle integration side of the business. This is where we provide engineering design and full electric drivetrain integration for heavy-duty vehicles in North America. Starting with an empty chassis with 4 wheels and a cab on it, we design and assemble the complete drivetrain with a combination of our own storage systems, either battery or hydrogen, and third-party components to deliver a fully operational vehicle. So Todd's going to do a solid deep dive on this later on in the presentation. It's important to understand that Hexagon Purus, while being a young company as a listed entity, we have a long technological and industrial legacy. We're not a startup, we're a carve-out from Hexagon Composites with solid capabilities built over decades. Our heritage on the composite cylinder side goes all the way back to the NASA space missions in the 1960s. So we have 6 decades of composite pressure vessel experience. We developed our first 700-bar hydrogen cylinder 20 years ago. And on the system side, we have 2 decades of system integration experience, designing, manufacturing, and mounting alternative fuel systems for heavy-duty vehicles. And this is in many ways exactly the same skill set that's needed to optimize battery and hydrogen electric drivetrains. And it is what has given us the know-how and the expertise to design the best battery and hydrogen storage systems in the commercial vehicle industry. It's what's given us the edge to stay ahead of the competition. And now, we're adding a new technology to our portfolio, cryogenic storage. We're firm believers in hydrogen and the place it has in the energy and mobility systems in the coming decades. And as explained earlier, we also believe that there won't be one dominating technology for the mobility sector. Each technology has its pros and cons, and the choice between them will be determined by the duty cycle and the total cost of ownership for the customer. So, just like we see battery and hydrogen technologies as complementary, so do we see the compressed hydrogen and liquid hydrogen as complementary. With liquid hydrogen, you get higher energy density, so you can store more hydrogen in less frame rail space, and thus get longer range. And that's the main benefit of liquid storage. And then there are some downsides. Liquid hydrogen is more expensive and more challenging to store over longer periods of time. And the technology is also less mature than for compressed. So we do believe, though, that liquid hydrogen could be highly relevant in the future, and so we're investing into the development of that technology. In April, we made an agreement to purchase 40% of CryoShelter, which is an Austrian technology company that's developed a revolutionary cryogenic storage technology for LNG, far superior to existing LNG storage tanks. And we'll now take the principles of that technology and develop a liquid hydrogen storage tank. It's not something that's just around the corner, so we don't expect to see any meaningful commercial volumes for this in the near to medium term, but the technology looks very promising. And we'll work together with CryoShelter to develop that technology further into a full commercial offering. So I won't spend any more time on this here today, but Todd will have a press conference actually on this from the ACT Expo trade show in California later today, together with Matthias Rebernik, the CEO of CryoShelter, and Eric Bickbus from Hexagon Composites. It's unfortunately at midnight European time, so it might be a bit late for many of you, but you're welcome to attend that one if you would like to learn more about CryoShelter and their technology. And if you don't want to stay up late, we'll also see if we can make a recording available on our website later on. So far, I've mostly talked about the technology and the company, and highlighted the leadership position we have in several of the key areas of zero-emission technologies. But the technology is only relevant and competitive in its application, how it's actually performing in real life. And in addition to being leading on technology, we're the company with the deepest know-how and the longest experience. We're also the company that has the most practical experience with the application of the technology. So I'd like to show you some examples of what we have done for our customers. Starting with distribution systems. Well, this is a picture of the distribution modules we built for Everfuel, a European company headquartered in Denmark that's working to build out a network of hydrogen refueling stations across Europe. The refueling infrastructure is a key requirement for hydrogen mobility to work. And our distribution modules are currently the most cost-efficient way to transport the hydrogen gas from the point of production to the point of use. This one here is the New Flyer Excelsior hydrogen bus. Transit is an ideal application for hydrogen. We work with many of the largest bus OEMs, like New Flyer, one of the largest bus manufacturers in North America. And here is one by Solaris, one of the largest bus OEMs in Europe, which we have supported for several years. Transit has typically been an early adopter of alternative fuels and is now one of the first segments to put hydrogen vehicles into serial production. And we work with many of the leading OEMs in both Europe and North America, helping them to accelerate their hydrogen adoption. This one is a Kenworth heavy-duty hydrogen truck. And Kenworth is one of Toyota's truck brands in North America. And as I showed earlier, long-haul trucking will be dominated by hydrogen because of the range and payload requirements. We've been working with Toyota on their fuel cell program in North America since 2017, and we expect them to put their first hydrogen-powered heavy-duty vehicle into production within the next 2 years. And here's another heavy-duty truck, a Freightliner e-Cascadia. We supported Daimler with their innovation fleet back in 2018 to 2020. And the innovation fleet was a fleet of battery electric medium and heavy-duty trucks that Daimler put out for their customers in California to use so that they could gain experience with the technology. We provided battery packs and full vehicle integration for the majority of that fleet. We have shown the Alstom Eilint Coradia a few times before. This is the world's first hydrogen-powered regional commuter train. We provided the storage cylinders for the initial prototypes, and we now provide the entire hydrogen storage system for the serial production. Rail's another good application for hydrogen. Predictable routes, high energy demand, plenty of storage space. So we're currently supporting other train manufacturers on their hydrogen programs. And we're also ramping up our efforts in the maritime segments. Due to the strong interest and high volume of customer requests, we set our maritime activities up as a separate business area last year and are involved in many different early development projects. And Purus Maritime just got its first order for maritime hydrogen cylinders. This picture, though, is the Vard Zero Coaster, a development project for a modularized bulk and cargo ship. The Norwegian coastal fleet represents almost 50% of all ship transport in Norway, and the fleet has a high average age of almost 30 years. With the target to cut 50% of greenhouse gas emissions in the maritime sector by 2030, a lot of new ships will be needed. And this is not only for Norway, of course, it's a global opportunity. But with a strong maritime sector, Norway is early out with a lot of ongoing projects. And so we have set up our business in the heart of the maritime cluster on the northwestern coast of Norway, one of the strongest maritime clusters in the world. We see this as a very large potential opportunity. And then we have aerospace applications. This is not a very high volume business for us, but it's very technologically demanding. Space is probably the most challenging operating environment you can imagine, with extreme requirements on the technology, performance, and safety. We work with 2 of the 3 large commercial space operating companies in North America. And we take our success in this area, the fact that these companies choose to work with us, as a sign of our advanced technological competence. So again, it's not a very high volume opportunity, but a great opportunity to showcase our capabilities and to continue to push the technology further. The best way to develop is to work with the most demanding customer requirements. So, as I've shown, we got a lot of practical experience with the different mobility applications and with vehicle OEMs. But so far, most of this business is low volume. Many of the segments are still at the stage where the technology is being adapted to the specific application, where the vehicle platforms are being developed and tested. So up until now, it's mostly been prototypes, test vehicles, and test fleets. But many mobility segments will soon reach the serial stage within a few years. And there are some segments that are already at the commercial stage, where the platforms have been developed and where volume is now in the early part of a steep growth curve. Hydrogen distribution is now going from a few tens of units a year into the hundreds. and transit is moving from the hundreds and into the thousands of units. And over the next few years, several more segments will reach the commercial stage. Battery electric trucks will come early. Many OEMs are preparing to launch their vehicles for serial production in 2024, like the ones we announced back in January. Passenger vehicles they're already on the road today, and more will come, although, as I mentioned earlier, we expect the majority of them to be battery electric. But we believe that certain subsegments will be hydrogen electric. The fuel cell electric trucks would likely be ready for the serial production stage closer towards the middle of the decade. Nikola is the first with planned start of production in 2023. And then there are some segments that will not likely be ready at large scale until a bit later. Trains and maritime vessels, for example. These are highly attractive applications, and they will be significant in size when they scale, but they're not expected to give any meaningful volume until 2025 or so. So aside from development work, of course, and demonstration sets. So we have a good mix of application areas that are ready today, and some that will come soon, and some that are a bit further away. But common for all of them is that we have built strong market positions with customers and are well placed to succeed. We have won significant business during the past 18 months in competition with others. Which brings me over to the topic of competition. We're not alone in this space. There are other players. There are essentially two classes of competitors today. Those coming from the specialty component side, like us, cylinder manufacturers like Worthington, Faber, and Prox. And then there are some that are coming from the other side, existing tier 1 suppliers to automotive OEMs, like Plastic Omnium and Faurecia. We stack up well against all of these, where our edge is the product, driven by our deep technological know-how, and also the speed to market, driven by our strong customer-driven and technology-driven organizational DNA. When it comes to manufacturing and aftermarket service, we have some way to go, compared particularly to the automotive tier 1s who have mass production and cost reduction as a core part of their DNA. However, mass manufacturing of composite pressure vessels, a highly engineered and specialized component, that's not trivial. It's actually quite challenging, as we also have learned over the past decades. There are very tight tolerances and zero room for mistakes. And remember that Hexagon is the company that has produced the most high-pressure Type 4 cylinders of any company. So we already have solid process knowledge. But we will also need to build stronger manufacturing capabilities at larger scale. And we will need to build up a good service and repair organization along with the rapid increase of the installed base. I do expect that there will be other players coming into the market in the future. This will grow quickly to become a very large market over the course of the next decade or so. And all the mobility segments and vehicle platforms will be transitioned away from fossil fuels and over to zero-emission drivetrains. And this will attract more players into this space. I'm not concerned about it. We welcome competition. We need competition. Any healthy market needs several competitors to fight for customer positions. We're confident on our own capabilities. We are industry leaders today, and we believe that we will be able to stay ahead of the competition and remain industry leaders also in 2030 and beyond. And the key to competitiveness will be cost efficiency. Lowest total cost of ownership for the customer. And this is why it's important to be an early mover and to win the early volume business so that we can get faster up the learning curve and faster down the cost curve. Over the past 12 to 18 months, we've reached several milestone agreements with customers in many of the key mobility segments: heavy-duty trucking, transit, and distribution. Nikola will be the first company to put a heavy-duty fuel cell electric truck into serial production, with start of production in 2023. Then the battery electric heavy-duty trucks will come in North America in 2024. And that's to meet the regulatory requirement in California that mandates that 9% of all trucks sold in 2024 in California has to be zero emission. We signed an exclusive multi-year supply agreement with one of the leading European transit OEMs in Q4. And then, of course, we have the distribution segment where we're experiencing significant growth from the global industrial gas companies, exemplified here by the multi-year global supply agreement we signed with Air Liquide last year. We've had significant commercial success, and we see that as a strong validation of our technology and our competitiveness. When we went public back in 2020, we set a revenue target of 4 to 5 billion NOK by 2025 and made a strategy and a business plan to take us there. Since then, we have seen a lot of supportive signals in the external environment around us. The regulatory environment has developed favorably and at a much faster rate than what we expected. The capital flows into green technologies and renewable energy have increased substantially as well, and customer interest for zero-emission technologies has skyrocketed. So in terms of the external environment, it's gone a lot faster than what we thought back in 2020. And in terms of our own execution and our own development, we've experienced significant customer success and have executed well on our strategic plans and projects. And as such, we're slightly ahead of schedule. We've grown from 180 million NOK in 2020 to 500 million NOK last year, and we've targeted 900 million NOK for this year. More importantly, the agreements, nominations, letter of intents, and so forth that we have signed have given us a good line of sight towards our 2025 target and increased our confidence that we will reach that target. And frankly, with the developments in the world around us, I'm not concerned about demand in the near to medium term. There's so much demand for zero-emission vehicles, and I expect that to continue to accelerate. This will most likely be an undersupplied market for many years to come, where the customer demand will be much higher than the industry's ability to deliver. For us, it's going to be all about execution. Our revenue target of 4 to 5 billion NOK must also be viewed in light of the size of the market opportunity. Mobility is a very large market, roughly 100 million vehicles a year. We expect our addressable market to be around $24 billion by 2030. And this is mainly then the value of hydrogen storage systems on board vehicles, which is the bottom portion of the bar, and 2, the battery systems, which is the green top of the bar. Mind you, the numbers for battery systems are only for North America, whereas the hydrogen numbers also include Europe and Asia. So if we focus now on the hydrogen, the largest bar, that's an addressable market of almost $20 billion by 2030. And at that time, we assume reasonably modest adoption rates for hydrogen vehicles. For passenger cars, only 1%. 5 to 7% for medium and heavy-duty trucks, and slightly above 10% for transit buses. And for battery electric, we assume a higher but still modest adoption rate of 21% for medium-duty trucks and 7% for heavy-duty trucks. So there are a few things that you can read out of this picture. The annual growth curve will be very steep since we're starting from almost zero. And the majority of the growth will come in the second part of the decade. That's logical, given that most vehicle platforms won't be ready to be put into mass production until around the middle of the decade. And with the 2030 adoption rates at these reasonably modest levels, there will be significant growth also after 2030. And if you assume that all vehicles will be transitioned to zero-emission drivetrains, then we're going to see secular growth at very high rates over the course of the coming decades. With good customer success, growing customer interest, and a rapidly growing pipeline, we've gained sufficient comfort and confidence to start embarking on the next phase of our development, the industrial scale-up phase. We're now in the process of increasing capacity in multiple locations simultaneously. We're building a new factory in Kelowna, Canada, which Todd will show you later in the session. We're moving our Maryland, US activities to a larger site. We're building a brand new cylinder manufacturing hub in Kassel, Germany, and also expanding the Wüsterach Systems facility in Weeze, Germany. And we have finally kicked off the construction of the new facility in China, which we are building together with our joint venture partner. That will go up in Shijiazhuang, a few hours southwest of Beijing. So with these expansions, we will have the necessary capacity to meet expected customer demand towards the middle of the decade. So that concludes my part of the presentation today, and I will now hand the word over to Michał Kleschinski, the Executive Vice President who heads up our cylinder and systems activities in Europe. Michał, please.
Thank you, Morten. Let's have a look into our hydrogen cylinders and systems business. Hydrogen is an important building block in decarbonization and energy independence. In the future, all hydrogen will be green, coming from electrolysis powered by renewable energy like wind power and solar power. Hydrogen is the ideal partner of renewable energy, as it allows to store large amounts of energy until it's consumed. It is therefore ideal to buffer the volatility of the renewable energy. Renewable energy is decentralized, so solar and wind is mostly not found where the energy is needed. Additional to storing the green energy locally, we must be able to transport the green energy to where it's needed. This is what hydrogen is capable of, and these are the solutions that we bring to the industry. Our solutions are able to capture the hydrogen-bound energy and bring it to where it's consumed in industry and transportation. We don't make the molecule, but we store compressed hydrogen and provide storage and transportation solutions to the end-user applications. Our solutions are therefore an important building block of the hydrogen infrastructure. In mobility, we provide onboard energy storage to all kinds of mobility, on-road and off-road as well. Hydrogen has nearly the highest gravimetric energy density of all energy carriers. The volumetric energy at ambient conditions is comparable low, and therefore we need to compress hydrogen to obtain also high volumetric energy density. So what does this mean? Well, it allows us to accommodate the required energy in the space available in the end-user applications like in a car or a truck. As an example, to accommodate the necessary amount of hydrogen on trains or transit buses, we need to compress the hydrogen to 350 bar, so to 350 times the atmospheric pressure. Other than compressed, hydrogen can also be stored in different states. For example, we heard about liquid hydrogen today. Still today, compressed hydrogen is a more mature technology over alternative technical solutions with a lower technical readiness level. More important, compressed hydrogen offers the best total cost of ownership in a broad range of applications. So all starts from a cylinder that can store compressed hydrogen. And the majority of the applications is in mobility. The cylinder is made from lightweight materials, mainly high-strength carbon fiber. We use these cylinders in a large variety of hydrogen storage and transport systems along the value chain of hydrogen. Our hydrogen systems serve from close to the hydrogen production up to the onboard storage of hydrogen in all kinds of mobility. Looking at the end-user applications at the bottom, it all starts with infrastructure. So from left to right, we provide stationary storage solutions. These are used close to hydrogen production, as well as in fuel stations where compressed hydrogen is required at pressures up to 1,000 bar. Our distribution solutions carry up to 1.2 tons hydrogen on road and in intermodal traffic. Finally, mobile refueling enables our clients to swiftly set up refueling operations. And these versatile solutions can serve the short and mid-term hydrogen demand, for example, for commercial vehicles, railways, and transit buses. Moving on to mobility, we provide solutions for the onboard storage of hydrogen for mobility on-road and off-road. For on-road mobility, it starts with vehicles as small as passenger cars. In a passenger car, our storage systems bring 6 kilograms and more hydrogen on board the passenger car, providing more than 200 kilowatt hours onboard energy storage. Heavy-duty trucks mark the upper range of the on-road mobility portfolio. We can design systems that enable the onboard storage of more than 100 kilograms of hydrogen. In between, we can offer on-road mobility solutions for transit buses, light and medium-duty commercial vehicles like delivery vans and box trucks. In the field of off-road mobility, we have developed a broad portfolio of hydrogen solutions for the railway space. Substitution of diesel trains that run on non-electrified tracks is the focus here. Similar in the maritime space, where the International Maritime Organization has ambitious targets set forth. So let's have a closer look at our solutions. The Type 4 cylinder is the nucleus of most of our solutions, the common denominator of our storage systems. Why a cylinder? Well, because this is the shape that allows to contain high pressure with a minimum use of material. A Type 4 cylinder is a cylinder nearly completely made from non-metallic materials. The outer shell is made from high-strength carbon fiber composites. Composites are just not a simple material, but consist of high-strength carbon fiber embedded in a plastic material. High-strength carbon fiber, as the name says, have a very high strength and are very lightweight at the same time. In the wall of the cylinder, the high-strength carbon fibers, which are impregnated with plastic materials, are stacked in a specific sequence. This creates specific properties, enabling the outer shell to cope with the high load caused by the internal pressure. And the stacking sequence is also key to a safe, robust, and efficient cylinder. As high-strength carbon fiber is fairly expensive, the efficient use of this material is key to competitiveness. The inner shell is a liner to contain the gas and assure leak tightness. In particular, the interface between the plastic liner, the only metal part in the cylinder, the so-called boss, is crucial to assure leak tightness over a lifetime of up to several decades. The boss is also the interface to the valve. The valve connects the cylinder to the piping network of our hydrogen system and is also a safety device. There's not one cylinder that can serve all solutions. All cylinders have different dimensions and different operating pressures. That depends on the use case. They are designed according to the different standards. Trucks are different than trains. Mobile storage is different than stationary storage, and buses are different than ships. Good news, although, we have tailored cylinder solutions for all applications. Well, when dealing with pressures up to 1,000 bar operating pressure, safety and reliability is paramount. This is where we bring more than 6 decades of experience to the table with a product that has undergone continuous design evolutions. A key success factor are our global product design, process design, and R&D teams. They operate leading-edge prototyping and testing facilities to assure maximum safety, innovation, and fast time to market. Hydrogen distribution is what we call bulk hauling of compressed hydrogen on road. These kind of solutions are the traditional way of hauling hydrogen as an industrial gas. We have more than 10 years operations experience in this kind of hydrogen distribution. A strong driver for this solution will be the green shift in hydrogen production, and will create demand to haul hydrogen from decentralized green hydrogen production to the users in mobility and industry. The module has a customized steel frame according to the dimension of standardized containers. Due to the standard dimensions, the container is compatible with several transportation solutions and doesn't require special chassis or carriers. The steel frame holds more than 100 Type 4 cylinders. The cylinder package itself is optimized to store the maximum amount of hydrogen without exceeding the maximum dimensions allowed in road transportation. Due to the low weight of the Type 4 cylinders, weight restrictions are not exceeded. Increasing the payload is most relevant for the total cost of ownership in hydrogen transportation. So maximizing the payload and reducing the number of trips is key to bring down the transportation cost of hydrogen. Today, modules up to 500 bar operating pressure are used. With 500 bar operating pressure, payloads of up to 1.2 tons of hydrogen are possible. Cylinders of higher operating pressures and therefore higher payload can be integrated as well. Unfortunately, such modules can't be reasonably utilized today due to the lack of the loading and unloading infrastructure. The module has a gas control unit representing the interface to the loading and unloading of hydrogen. This container is smart ready. It means all valves could be remotely controlled, monitoring of pressure and temperature and other relevant parameters can be integrated. This allows the operator of this solution to integrate the module into his gas logistics and optimize loading and unloading operations. Stationary storage. Stationary storage of compressed hydrogen is required along the whole value chain. For example, storage of hydrogen adjacent to the electrolysis with renewables. The volatility of the renewables creates the demand for a buffer solution. On the other hand, dispensing of gaseous hydrogen requires stationary storage up to 1,000 bar to enable short refueling times versus direct compression. The stationary storage leverages the system's know-how from distribution applications and other standardized gas storage systems. At pressures larger than 500 bar, our more expensive ground storage solutions create a better total cost of ownership due to the significantly higher lifetime of our Type 4 cylinders compared to conventional low capex solutions. While lightweight due to Type 4 cylinder matters for mobility, it is the Type 4 cylinder's durability that matters in stationary storage. In a recent project, 4.4 metric ton 500 bar stationary storage has been realized as part of a train refueling station. Next, the mobile refueling system. It represents a mobile and highly flexible solution to refuel commercial vehicles. The current version enables refueling of up to 350 bar and is ideally suited for fueling of transit buses, medium-duty trucks, and trains. Our clients like Bosch and Deutsche Bahn are using these solutions to support pilot operations with fuel cell electric trucks and trains. Other than stationary fuel stations, the mobile refueler is ready for operation in short time. During the ramp-up of the hydrogen infrastructure, the refueler is therefore an important building block. A mobile refueler consists of two units: a tank container that is used to haul the hydrogen on site, and the actual refueler. The refueler contains the equipment to dispense the hydrogen. The dispenser is fed from the high-pressure storage inside the refueler. Before being dispensed, the hydrogen is cooled down to increase the fueling efficiency. After filling of a vehicle is completed, the onboard compressor is replenishing the 500 bar storage to be ready for the next refueling. This system, as we see here, can dispense in back-to-back operations up to 4 buses, and during a day, approximately 10 buses can be fueled. Decarbonization of transport is a priority. So looking at heavy-duty trucks used in long-haul operations, weight and availability is crucial. This is where fuel cell electric trucks have a significant advantage over pure battery electric trucks. Generating the vehicle's range mostly from hydrogen enables short refueling times, combined with a comparable low weight. This allows to maximize the payload and therefore reduce the total cost of ownership. The application in heavy-duty trucks require custom large volume cylinders at 700 bar operating pressure. This creates longest range at the lowest possible complexity of the system. The hydrogen storage system is specifically designed for reliable and safe operation. Additionally to the cylinders, the system integrates gas management functions. This ensures that hydrogen at the desired amount and the desired pressure can be handed over to the interface of the truck. The system is designed for inline assembly within the tuct of the truck OEM's assembly. The option to integrate further equipment and accessories of the truck's powertrain allow to further optimize the assembly at the truck manufacturers. The system's architecture is leveraging decades of knowledge from the alternative fuel space, especially from natural gas. Therefore, our systems are based on the experience of millions of miles in operation. We see here an example of a Class 8 heavy-duty truck like it's operated in North America. In this system, 4 large 700 bar cylinders will enable to store more than 70 kilograms of hydrogen on the vehicle itself. Using additional cylinders mounted at the frame rails could lead to more than 100 kilograms on the vehicle, enabling even longer range operations. Fuel cell electric buses are at the forefront of hydrogen adoption in mobility. The depot-based operations allow swift and efficient installation of the necessary infrastructure that is independent of the rollout of cross-country infrastructure. Our solutions serve buses up to a length of 18 meters. The standard hydrogen storage system can easily be adopted to the typical roof layouts of a bus OEM. This allows standardization and scale at an early stage. Longitudinal-oriented cylinders on the rooftop enable maximum hydrogen storage at a minimum cylinder number, reducing complexity. An included fuel management system is controlling pressure and flow to meet the demand of the vehicle's powertrain. While high-speed train lines are fully electrified, still a lot of train lines beyond the main lines are non-electrified. Today, such lines are operated by diesel-electric trains, and further electrification is cost and time intensive, and therefore fuel cell electric trains are an attractive solution for the replacement of diesel trains. Fuel cell trains can be a drop-in replacement for diesel trains due to the high range of the fuel cell trains. This enables fast adoption as fuel cell trains can operate in parallel to diesel trains in the long period until total decarbonization of rail operations is completed. Other than buses, the train layouts are not standardized. Therefore, customized solutions are required. As we see here, packages on the rooftop or within the rail cart are possible. Rolling stock has extensive operational lifetime of partly more than 30 years. In addition, rolling stock has high requirements regarding the load-bearing capacity and the robustness of the hydrogen storage system. This requires specific designs in accordance with the requirements of the major railway standards. Similar in the maritime space, so high technical requirements meet an even higher level of customization. Based on a variety of hydrogen cylinders with up to 32 kilogram hydrogen storage capacity per cylinder, our naval architects designed the subsequent systems to accommodate the cylinders on board of ships in compliance with the maritime regulations. Hydrogen systems can be packaged on deck or on top of the superstructure. In the latter case, lightweight systems are essential. Due to the required amount of hydrogen, also swappable containers for improved refueling, respectively change of fuel storage, are possible solutions. Piping and gas management is designed in compliance with the maritime regulations. And in order to serve this particular field of the business, Hexagon Purus has set up a dedicated entity with Hexagon Purus Maritime. So if we now look at the total addressable market for our diversified portfolio, we see an addressable market volume of $20 billion in 2030. Infrastructure-related applications will dominate in the early years and pave the path for future mobility. Hydrogen distribution will dominate the infrastructure market in the first half of the decade. Being less dependent on a fully fledged infrastructure, in particular transit buses, will also drive the growth out of the gate and be a major part of the addressable market in the early years. Mobility will get more dominant in the second half of the decade, And they, especially transit bus, but also commercial vehicles, are expected to drive the demand. Like commercial vehicles, like delivery trucks, but also larger medium-duty trucks will be a driver. We expect heavy-duty trucking and long-haul applications to be the largest driver of growth. Passenger cars were high on the agenda of the OEMs in the early phase of the industry, but today we see that battery electric vehicles will dominate this market. Nevertheless, there will be applications for fleets and heavy passenger cars. Although this addressable market represents nearly 50% CAGR till the end of the decade, all these projections are based on fairly modest adoption rates. Public transportation is an early adopter, not needing extensive infrastructure to ramp up. Therefore, we expect double-digit adoption by end of the decade. In order to serve the addressable market, we are expanding our related production capacities within the relevant market in the US, EU, and China. So looking from west to east, in Maryland, we are moving our operation to a brand new facility in Westminster and more than doubling our footprint for dedicated hydrogen cylinder production in North America. Focus will be on larger cylinder production. And we have a vertical integrated production line which is getting ready to cover the growing demand, in particular for the heavy-duty truck space in North America. Furthermore, special cylinder production capacities are on site, and Westminster also serves as our engineering center of excellence for the North American market. This site offers multiple expansion capabilities from additional cylinder production capacities to system assembly. The plant will be fully operational before end of this year. And now moving on to Europe. So in Europe, we are expanding our cylinder and systems related capacity. First, in a greenfield facility in Kassel, Germany, we are increasing our dedicated hydrogen cylinder production capacity. The new site will host highly automated mass production lines for small and large cylinder, representing leading edge regarding productivity. In the dedicated building on campus, we are building a technology and engineering center. This building will bundle our current pilot production capacities and extensive material and cylinder testing capacities. Commissioning of a new production line is planned to start within this year. The site also allows further expansion with the potential to more than double the currently built-out capacity. On the hydrogen system side, we are expanding our system assembly capacities for infrastructure and mobility systems in Weeze, Germany. The expansion adjacent to our existing facility will more than threefold the capacity for large hydrogen systems, like for distribution and refueling. And for mid-sized systems used, for example, in transit bus and rail, we will more than fivefold our capacity for systems assembly. The facility will be focused on system assembly and production of piping and gas management components. The new buildings will allow us to expand our vertically integrated metal processing in the existing infrastructure in line with the assembly capacity expansion. New office facilities will also host our growing systems engineering team in Europe. Our Asia JV, Enric Hexagon, just recently broke ground for our new greenfield facility in Shijiazhuang, approximately 1.5 hours southwest of Beijing. This site will serve as our Asian hub, including production capacities for hydrogen cylinders and assembly capacity for hydrogen systems. The current expansions which are in progress are expected to create a global revenue capacity in the range of 450 million euro in total in 2025. We will continue to add additional production assets to these sites to continuously expand our capacity in line with our anticipated growth. We are, and as Morten also expanded on, the first mover, not only in Type 4 cylinders in general, but also in hydrogen. The same is true on the system side. We bring more than 2 decades of experience with alternative fuel systems to the hydrogen space. In order to stay leading in our field, we have a clear agenda to drive down cost significantly while the business grows further. I've illustrated this here with an example of a heavy-duty truck hydrogen storage system. The system is holding 4 700 bar cylinders, enabling long-range operation on the truck. Innovation around the product design and the production process will not only improve the offering and the customer experience, but also be the first pillar of cost down. Efficient production is the next pillar of the roadmap. From our other Hexagon operations, we know how to manufacture more than 2 million composite cylinders per year. We will introduce this leading-edge mass production technology in the hydrogen space as well. And finally, standardization. Already today, we have cylinders and components that we use in on-road and off-road mobility, as well as in rolling stock. We will continue along these lines, so the standardization in combination with supply chain development will enable further cost down. In total, we see a price level of $650 per kilogram hydrogen stored. 20,000 trucks per year are already sufficient to reach this level. And this finally is a level we expect to see the second half of this decade. So in summary, we have built our technology in hydrogen cylinder and hydrogen systems over decades. We have a product portfolio for our broad range of infrastructure and mobility applications along the value chain of hydrogen. We are expecting a global addressable market of $20 billion in 2030. We're in the process to increase our global capacity and expect to reach a revenue capacity in the range of 450 million euro in 2025. Finally, innovation is key, and we will continue to drive costs down to remain leading in the industry. So thank you for listening in so far. We will take a 5-minute break before we continue with my colleague Todd, who will talk on heavy-duty truck applications in North America.
Welcome back, everyone, and hope you all are ready for the second leg of today's Capital Markets Day. Now it's time to welcome our EVP Systems, Todd Sloan, that will go through our heavy-duty truck applications. All yours, Todd.
Excellent. Thank you, Matthias. I will now talk about the zero-emission systems and vehicle integration business based in North America. The Hexagon Purus Systems business unit is all about getting electricity to the wheels of commercial vehicles in the safest, lightest, and most efficient way possible. We understand the entire energy grid, taking into account the value chain from well to wheel, with sustainable development programs in place for second and end-of-life solutions of our energy storage systems. Earlier, we mentioned, Morten and Michelle both mentioned 6 decades of energy storage experience, but we also have over 20 years of systems and commercial vehicle experience that has led to this point. In that time, we have installed clean energy solutions on tens of thousands of commercial trucks and buses, accumulating billions of miles. We have served the majority of commercial vehicle OEMs in North America and have taken that knowledge to create leading battery and hydrogen storage solutions and full integration for both battery and fuel cell electric vehicles. With well over 1 million miles accumulated in the past few years on the Daimler Innovation fleet and other programs, we are well positioned to help grow the zero-emission commercial vehicle industry in North America and eventually expand to other global locations. In the year 2000, we started a company called Enviromech Industries based in Kelowna, British Columbia, Canada. Having started my career in a tier 1 company supporting Western Star Trucks, which was an OEM located in Kelowna at the time, it was an obvious place to start the new business as they were already a customer. Western Star is now owned by Daimler Truck North America and located in Portland, Oregon. But a significant tier 1 supply chain still exists in Kelowna, which is only a half-day drive to Portland. The original business plan of Enviromech focused on hydrogen storage systems, which clearly proved to be a bit ahead of its time. Although we did many hydrogen systems in those early years, we quickly changed focus to design compressed natural gas systems for the commercial vehicle market. In 2010, Enviromech merged with our biggest competitor at the time to form Agility Fuel Systems. In 2014, Agility entered a JV with Hexagon Composites, which, as you know, was eventually fully acquired to become Hexagon Agility. Acknowledging that there was an increasing interest in zero-emission solutions for commercial vehicles, in 2016, we started a battery system development program. Around that time, we also continued growing our hydrogen storage business with a successful contract to Toyota. As pioneers in bringing clean energy solutions to commercial vehicles in North America, we realized an agnostic approach to getting electricity to the wheels with battery or fuel cell electric vehicles was the best way for us to move forward. We were successful in being awarded Daimler's Innovation Fleet for both battery packs and full battery vehicle integration. We also integrated a number of other medium and heavy duty battery electric vehicles, leading to successful awards from Hino and other large established OEM. We will launch the new factory in Kelowna later this year. And once that is ramped up, we will start working on our next factory locations near our customers. So what exactly do we do? We typically start with a new factory-built diesel truck. Then we remove the entire drivetrain. As we scale up, it's likely that the OEMs will do this portion for us. But for now, at small volume, we do it ourselves. What's left is a chassis with a cab, axles, and wheels. At that point, we prepared for electrification with routing and clipping of low and high voltage cables, coolant systems, and various other components. Then it moves to the next step. To clarify, full vehicle integration like this is only a part of my business unit, with the remainder being the shipment of battery and hydrogen systems directly to OEMs for their factory install. Next, we install our patented ProPack battery packs. Each pack can store up to 330 kilowatt hours of energy, although some applications only require our smaller 70 kilowatt hour version. For Class 8 battery electric applications, it's typical to store 2 or more of these large packs for capacity of 660 kilowatt hours or more. For fuel cell electric applications, the battery systems are smaller but still required. Our battery packs are designed to install in about 2 minutes on a factory line, meeting the requirements of our OEM customers. Our best-in-class performance metrics are focused on providing a lightweight, high-capacity packs that allow electrical and thermal energy to flow easily, thereby reducing stress on the battery cells. Reducing stress on the cells improves their safety and lifespan. We also focus on providing the most kilowatt hours of energy for a given length of wheelbase. A metric we have learned over the past 20 years is critical to our customers that highly value small turning radii in tractor applications. Next, we install our patented accessory drive module. All of the components that used to be powered from belts and pulleys spinning off of a diesel engine now have to be electrified. Like our battery packs, this needs to install in minutes on a factory line. All of the heating, air conditioning, power steering pumps, air brake compressors, 12 and 24 volt systems, and other components are assembled into this module. We have designed our system to be one of the quietest in the industry and are constantly improving maintenance access for predictive and preventive measures to ensure the vehicles have as little downtime as possible. Next, we install our patented power electronics and distribution modules. They can either be mounted vertically behind the cab or between and flush with the frame rails. Billions of miles of experience have proven better durability above rails on commercial vehicles. So when possible, this is our suggested location. To this, we integrate cameras, grab handles, trailer connections, everything that would typically be found on the back of a cab of a truck pulling a trailer. Like our accessory drive module from the previous slide, we put a strong focus on easy maintenance access and with options for charge ports, power to grid, and electrical power takeoffs to run refrigerated trailers or other pumps or compressors. This design is well suited to support various vocational applications. At this point, the vehicle is ready to move electrical energy to the motors that power the wheels. One or more e-axles or central drive motors are installed onto the chassis. Hexagon Purus has developed software and validated numerous e-axle and motor combinations. Most typically, the e-axle company provides us with their drive inverter, which we install in our Power Electronics Pro Cab. This is also the stage where various axles, suspension, and brake options are installed. The install is now complete, and the result is a high power, high torque, highly efficient battery electric commercial vehicle. To make a fuel cell electric vehicle, we first do everything I just described to make a battery electric vehicle. We install a ProPack battery system, the accessory drive module, and an e-axle. Next, we install our ProCab hydrogen storage system, and to that we attach our ProCab power electronics module, which is only slightly altered for fuel cell applications. The fuel cells come from various third-party suppliers, and we typically mount 2 of those to the vehicle. We then install the Hexagon Purus fuel cell thermal management system and Hexagon Purus developed vehicle level software that supervises the battery electric vehicle, the hydrogen system, the fuel cell, and the e-axle. That Hexagon Purus software supervises all of it. The result is a fuel cell electric vehicle. It has all of the features and benefits of a battery electric truck with the added benefits of longer range and significantly faster charge times. Our addressable market for both battery and fuel cell electric commercial vehicles in North America is expected to reach $4 billion by 2030. Our agnostic approach means we don't have to debate which zero emission technology is better. Both BEVs and FCEVs will be ready to support our customers with their different locations and applications. To support this growth, we will need to expand our North American locations, the newest of which is our soon-to-be opened microfactory in Kelowna, Canada, where we will now present a short video.
Hexagon Purus is excited to announce our new highly automated microfactory built in beautiful Kelowna, British Columbia, Canada. With Hexagon Purus's growing global footprint, Canada will see our newest factory opened by the end of this year. The country is pledged to have net zero carbon emissions by 2050. Canada is the only country in the Western Hemisphere capable of manufacturing a zero-emission vehicle from start to finish. Canada's energy infrastructure ensures all segments of the supply chain can be supplied cleanly and sustainably. In British Columbia, the Clean BC Plan is one of North America's most progressive climate action plans, and in 2021, British Columbia became the first province in Canada to release a comprehensive hydrogen strategy. With sustainable and clean resources to produce green and blue hydrogen, battery cells, and access to one of the largest seaports in the world, British Columbia is an obvious choice for our newest factory. Just a few hours' drive from Vancouver and near the Canada-USA border, Kelowna's wineries, golf courses, ski resorts, mountains, and lakes make it an obvious choice for attracting the industry's top talent. Near an international airport and the University of British Columbia, the 80,000 square foot microfactory will produce battery packs and hydrogen systems for our growing list of OEM customers. This will also serve as the company's research, development, test and validation center for battery electric and fuel cell electric vehicle integration. When complete, the factory will be able to produce revenue of $250 million and will employ 150 people. We are very excited to open our new factory soon and will host many company and industry events as we take another step in fulfilling our vision of clean air everywhere.
Okay, thank you. It's important to understand that when we use the term microfactory, that doesn't mean there aren't large gigafactories strategically located to feed it. As an example, we need battery cell suppliers with at least 15 gigawatt hours of capacity and carbon fiber plants able to produce millions of pounds annually in order to reach economies of scale to drive down costs. When considering logistics, packaging efficiency, and sustainability, however, the final assembly of battery packs and hydrogen systems makes good sense close to where the final OEM vehicle assembly occurs. The Kelowna Microfactory will be used to continuously improve and validate our highly automated manufacturing process, the improvements of which will be replicated at various new locations as the industry grows. It's logical that as industry volumes increase, the size of microfactories will also continue to grow over time. When considering the price targets of commercial battery packs, it's important to understand that not all packs are created equal. For battery electric passenger cars, most OEMs are planning cell-to-pack designs, cell-to-pack, that can leverage their relative light duty cycles and driving conditions to bring down costs significantly as volumes increase. As a result, most of the pack cost is associated with the battery cell. For medium and heavy duty commercial applications, however, the duty cycles are much more harsh and the packs needed to incorporate many features, including cab access steps, side impact, ground debris protection, extreme spikes in power charge and discharge rates, all while surviving in extremely harsh ambient commercial conditions, including temperature extremes, road salt, gravel bombardment, and the high forces of trailer coupling, among others. Due to the amount of energy stored on board, there's also more content needed for thermal management and the overall size and mass of the systems. Although most of the cost of our commercial vehicle battery systems comes from raw materials, Hexagon Purus' focus on automation and scale will allow us to drive down costs and stay competitive with our peers. Through these efforts, we expect battery pack prices across sectors to converge through 2030, and we see a clear path to sub $200 per kilowatt hour pack pricing by that time. Thank you. This concludes my portion of the presentation, and I'll now hand it over to Dilip, who will go through the financials and outlook.
So for the benefit of those who are new to our story or have missed our Q1 update, this is where we are in 2022. We continue to expect revenue of 900 million NOK in 22 and EBITDA losses to widen by roughly 50% from 2021 levels of 265 million NOK. Now, let's talk about our capital deployment priorities. Our medium-term goal is to grow revenue towards 4 to 5 billion NOK by 2025. As Morten has previously covered, we continue to build a robust book of business that substantially de-risks this target. This revenue growth will require significant amounts of working capital investment. Next, in order to execute on this revenue plan, we will need to scale up the organization by adding skilled resources to support key functions in production support, engineering, product development, and supply chain, to name just a few. We will also need to invest in infrastructure and back office functions to support this revenue growth. We will also need capital investments. Recall, Hexagon Purus is a spin-off from Hexagon Composites with limited starting capacity. And we will go over CapEx in more detail in just a couple of slides. And finally, in order to drive revenue and adoption, we will need to reduce cost. This will take spend initiatives in product development as well as process innovation to drive towards the cost reduction targets that Michael and Todd talked us through. Okay, on to EBITDA. So as we grow our revenue towards our 2025 target and beyond, we expect that our contribution margins, which are already positive today, should increase as we take cost out, even as we share savings with our customers. This, combined with the benefits of improved operating leverage, will drive significant EBITDA improvement. Our goal is to achieve break-even EBITDA in 2025, and we believe we can achieve longer-term EBITDA margin in the mid-teens range with a suite of high-demand, highly engineered, non-commodity products. We believe that over the course of this journey, roughly 40% of EBITDA improvement will come from a reduction in cost of production, with the remainder coming from the benefits of operating leverage. On to CapEx. We expect net capital expenditures of the order of 750 to 800 million NOK through 2024 in order to drive the capacity we need to meet our 2025 revenue goal. Note, these numbers are net of approximately 200 million NOK of external debt financing we expect to secure for Wystrach in Weeze. These also do not include certain acquisition consideration payments for Wystrach and Cryoshelter, as well as some capitalized product development initiatives. I want to be clear that these CapEx numbers reflect our currently approved plans, how we view the world today. It is possible that we could add to these plans should we see the need to do so based on customer demand. And then for financial modeling purposes, it's a little challenging, right? It's to accurately predict the timing of this cash flow. But, one could assume 30 to 40% of this amount expended in 22, roughly half in 23, and the remainder spilling over into 24. And with that, I'll turn it back to Morten.
All right. Thank you, Dilip. So we're now approaching the end of the presentation. I hope this has been a useful session for you and that we've been able to give you some more insight into Hexagon Purus and our business. We're very proud of our company and excited about our future. We find it meaningful to contribute to positive change and to help drive the energy transition towards a more sustainable zero-emission future. So I would like to end this session by summing up the key takeaways from the presentation and to highlight how Hexagon Purus is very well positioned for success in the years ahead. We have a large and rapidly growing addressable market. We have industry-leading energy storage technology for vehicles, both on the hydrogen cylinder and the battery side. We have solid practical experience with that technology across the whole mobility spectrum. We have solid experience with world-class OEMs and have validated our technology with the industry's most demanding customers. We have an established global organization footprint with solid engineering and manufacturing capabilities ready to scale. And we have commercial momentum in a very supportive environment where we, over the past 12 months, have significantly de-risked our business plan. We're very well positioned to succeed. We're confident on delivering on our revenue ambitions for 2025, and we're confident that we can remain a leading player in the industry for many years to come. So that concludes our presentation for today, and we'll now open it up for Q&A.
Thank you, Morten. I guess we can dive straight into the question, guys. So we'll start with the first one for you, Dilip. Just reiterating what you just said. What will total CapEx be in 2022?
Yes, so again, we've guided to 750 to 800 million NOK in net CapEx over the course of the next 2 to 3 years through 2024. And the best way to think about the cash outflows is 30 to 40% of this number expended in 2022.
Thanks, Dilip. And I guess the next question is maybe for you, Todd, if you're with us. We note the long-term target of $650 per kilo hydrogen in 2030. Could you give some visibility to what decrease that represents in terms of today's costs?
Yeah, sure. So at a complete system level, that 650 target for 2030, we do need that 20,000 vehicles of volume to achieve that. Right now, we're, depending on the project, these are really low volume projects where we're doing 1s and 2s and 3s and 4s. We're in the sub $2,000 range. At around 1,000 truck level, we can see that number get to $1,000 a kilogram. So you can kind of interpolate between, near 2,000 today down to 650 by 2030.
Okay, thanks, Todd. And I guess maybe the next question for you as well. What is the typical range in kilometers for a heavy-duty truck, and how many kilograms of hydrogen will this require?
It depends on the application. There's some heavy-duty trucks that would work in like a port drayage scenario, would pick up a load from the port, bring it inland, turn around and go back. Those trucks, 150, 200 miles would be enough for a daily use, so 300 kilometers. We have some applications long haul over the road where customers are looking for well over 1,000 kilometers of range. If we think about our 73 kilogram system, and you've just for easy math and somewhat conservative math, think about 6 miles per kilogram of storage of range, and then as Michel suggested earlier, we can get that up to 109 kilograms of storage. Multiply that by 6, and then you get an idea of what kind of range we're talking about. When you add in liquid hydrogen, you all of a sudden can 2x those numbers. So we will easily be able to achieve well over 1,200 kilometers zero emission with liquid hydrogen, and with compressed, I could easily see us getting to that 1,000 kilometer mark.
Okay, thank you, Todd. And then I guess this question goes to you, Morten. Can you talk about your TAM by geography? You mentioned expanding capacity at your existing sites after 2025, but you're also expecting to add manufacturing sites at new locations?
Yeah, so at this moment, we're of course focusing on our existing footprint and expanding that. And then, of course, as you look into the future, this will all depend on where are the customers moving, because that will determine where we need to be. But I think the first scale-up we're now doing at those sites, we're obviously preparing those for also even higher scale in the future, and it's probably more capital efficient to focus on expanding existing sites rather than building new sites. But clearly, with the kind of size this market will take on, I'm quite sure that we, in the future, will also construct new facilities in new locations.
Thanks, Morten. And I guess maybe this is one for you, Dilip, but the other guys could chip in if necessary. Have inflation impacted your new factories under construction, and if so, by how much?
I'm not sure I can quantify how inflation has impacted the cost of new factories, but I think it's fair to say that the cost of new construction is up significantly from 2 or 3 years ago. The CapEx guidance we've provided, I think adequately reflects that inflation.
Thanks, Dilip. And then the next question, can you indicate the level of revenue growth or market share you are assuming beyond 2025 needed to achieve the mid-teens Ebitda margin target by the end of the decade?
Yeah, I don't think our crystal ball goes out that far, unfortunately. But I think it's fair to say that there is precedent for highly engineered, highly technical products like us to garner double-digit EBITDA margins over time. And so the key to achieving double-digit EBITDA margin really is a combination of improving contribution margins through cost reductions, which Michel and Todd have talked about. And then, there is a really powerful operating leverage impact over time. Thank you,
Dilip. And then maybe this is one for you, Morten. The major contract awarded, are they locked in with material prices, or can increased prices be pushed over to the customers?
Well, I think for the most, when we do business, we try to, I mean, the OEMs and the customers, they're used to material cost moving up and down. And it's not so that the cent for cent everything is adjusted up and down with raw material movements. But it's clear that for most of the contracts that we deliver, we have an ability to also adjust our end prices. And it's not, I mean, the business is used to working with this. When you have things that are going through the roof in terms of cost or falling very, very sharply, it's clear that this will also be reflected in the end price of what you provide.
Thank you, Morten. And then a new question here. You mentioned near the start of the presentation that Purus can also enable zero-emission supply chains for mobility. Can you outline how you can optimize your manufacturing process to minimize its carbon footprint?
Well, I think this is the big question that everybody is working with these days, because you really need to look through the entire chain. And so it starts with the easier things of using renewable energy instead of energy driven from carbon. And then you have to look through all of your materials that you're using to use sustainable, renewable materials. And so this goes all the way from the material you source all the way through to the product. And I think there are 100 to 1,000 type different smaller steps that you need to take in order to get there. And I think it's clear that we're not going to get there in 2023 or 24. Some of the material that's being used for either for batteries or for steel or for any material has a lot of carbon content today. But I will say that we work with our suppliers. Our customers are working with us. So the entire supply chain is trying to figure this out, and I think over the course of some years, we will get there.
Thank you, Morten. And then the next question is for you, I believe, Todd. I think you have to walk us through the capacity figures on trucks again. What is the size of one cylinder? Today's system is indicated at 73 kilos. How many cylinders is that? If you do double, you get 146 kilowatt at 6 kilometers per kg. That is below 1,000 kilometers. How did you get to above 1,200 kilometers?
So when I said 6 per kilogram, that was miles, so that's 10 kilometers per kilogram. That probably helps the math. One of the cylinders, one of the large 705 millimeter cylinders that Michel's business unit makes, holds 18.3 kilograms of hydrogen. So 4 of those get you to the 73 kilogram number, and 4 of those behind the cab with 2 rail mounted gets you to the 109 kilogram number.
Thank you, Todd. Then the next question, I guess that also is for you, Morten. The large LOI and the nomination reported in Q1, will there be an announcement confirming or firming up the announcements? If so, when?
Yeah, as we know from history, it takes usually a long time from the point of nomination to things are being firmed down. And particularly now in this nascent stage of the industry, it will take a while before we know precisely what sort of volumes are going to come exactly when with these OEMs. So it's not, we're not concerned that it's taking time. We're used to it taking time, and it can be anywhere from 6 to 9 months after nomination.
Yeah. Thank you. And then one question for you, Michael. What is the average selling price of a cylinder or a module for you?
Yeah, good question. Although difficult to answer given the very diversified portfolio that we have. It goes from cylinders holding less than 1 kilogram of hydrogen up to cylinders holding more than 30 kilograms of hydrogen. Modules for commercial vehicles, for transit buses, all different in terms of nature of their holding capacity of hydrogen, as well as the systems and the accessory transport or distribution modules from 10, 20, 30, 40 foot. So there's a broad variety, so there's not one ASP that we can reduce this to.
Thank you, Mikael. And then a question for maybe you, Morten. Can you provide a comment on the potential, or maybe Michael as well, can you provide a comment on the potential recyclability of your Type 4 cylinders in the future?
Yeah, so recycling and especially sustainability is high on the agenda. So by today, still, as we already heard, a lot of these materials have a significant carbon footprint. So that is something, a topic that we will work while moving on to in order to also assure sustainability or increased sustainability of the products in the future.
And maybe a follow-up question there, Michael. Can you comment on the use of composite in the cylinders? Is there any new material that is easier to recycle than composites used today?
Yeah, I mean, composite itself are a kind of heterogeneous combination of different materials. So key is, of course, to dissect and then subsequently to recycle or even downcycle in the first step. We have significant R&D efforts with our global teams, and subsequently these are also topics that are on our agenda in the future.
Thank you, guys. I think that concludes the question we have received from the audience today. So behalf on Hexagon Purus, I would like to thank you all for spending time with us today. And we look forward to seeing you soon again. And thank you very much from all of us in Oslo. Bye.